Here we're going to do something really nice. We're going to derive the formula for the volume of the cone. Cone with height h and radius r is, and we'll actually figure out what it is. Now, how do you get a cone of radius r and height h? The answer is you rotate. If I take this line where the height is h, or that's h, and this is r, and I rotate this about the x-axis, I'm going to get a cone. And you know what? The height of the cone is going to be h, and amazingly, the radius is going to be r. So clearly, this point would be h, r. And this point is 0, 0. So the equation of the line that I rotate will be y is equal to r over h times x. And to make sure it works, well, when you plug in 0, 0, if x is 0, that's 0, and y is 0, that's 0. And if x is h, if this is h, you should see those h's canceling out, and you just left with r. So when x is h, y should be r. This is the equation of the line that we have to rotate. And we're going to rotate it from here, from 0 to h, when x goes from 0 to h. I hope this is crystal clear. If you rotate this line, that line, you are going to get a cone. You are going to get a cone. And the radius of the cone is going to be r, and the height of the cone is really going to be h. It's pretty neat. Okay, so y is equal to r over h squared. Now, the volume is the integral, so we're going to do dx. We are revolving around the x-axis. So, basically, we take this disk, which has a delta x base, and we're going to get pi r squared, where r is this distance, which is y. So we're going to get the volume is the integral of pi times r squared dx. But that's r. It's a different r. Okay? It's a different r. Actually, it's y. So we get r over h x all squared. And it's gonna, these slabs that are being rotated, well, they go from x equals 0 right here, let's do this color, x equals 0, all the way up to x equals h. Only over the purple are we gonna have slabs that we are gonna rotate around the x-axis. It goes from 0 to h. Okay? And it's a really simple integral. Let's just clean it up. Integral 0 to h, you have pi times, you have r squared over h squared times x squared dx. And this having nothing to do with x can be factored in front. So we have pi r squared over h squared times the integral of x squared dx from 0 to h. Okay, so we have pi r squared over h squared. The integral of x squared is x cubed over 3 from 0 to h. Now, we have every right to factor out stuff. This is pi r squared over 3h squared times x cubed from 0 to h. So we have our constant in front, pi r squared over 3h squared times, you plug in h for x, you get h cubed, minus, you plug in 0 for x, you get x. So we have that constant in front times, well, that's h cubed. And we are done. Because if you kill off 2 h's in the bottom and 2 in the top, you have 1 h in the top left. Is pi r squared h divided by 3. That is the volume of a cone, whose height is h and whose radius is r. It's not because I told you. We derived it. So basically, if I give you a cone, now I guess for my cone, the point where these two lines meet must be right above the center. Okay, they must meet right above the center. So, if that height is h and the radius of the circle in the bottom is r, then this is it. You know, if h is 7 and r is 2, you get pi times 2 squared times 7 over 3. Looks like 28 pi over 3. This is 4 times 7. 28 times pi. That's what I wrote. Over 3. So don't memorize formulas. Derive them. At least know how to derive.